Imagine you had a planet orbiting around a star, and every once in a while that planet passed in front of the star. Now the planets are obviously much smaller than the star, but wouldn't the planet block out a tiny bit of the light? And if we had a sensitive detector here on Earth, we could actually notice that the star just dimmed a little tiny bit. It was a particular kind of variable star. And then when the planet was not in front of the star, there would be no change in brightness. So the star would appear a constant brightness for long periods of time. And then as the planet moved in front of the star, we would lose a little bit of the light, and then the star would go back to being its normal brightness again. Again, that's something that we could actually detect here on Earth. When a planet goes in front of its star and blocks out a little tiny bit of light, that's called a transit. We had a transit of Mercury not that long ago. Now, obviously, if you had a bigger planet going in front of the star, it would block off more light than if, say, you had a little tiny planet going across the star. So by the amount of light that is actually lost, we can say something about how big that planet is relative to the star. And by how long it takes the star, the transit to occur, and how long it is again until the next transit occurs, we can figure out the orbit of that planet around the star. So the transit method is very powerful. You can get a lot of information from that. But of course, we need to actually see the transit. We have to be in the right alignment so that we actually can see the planet going in front of the star rather than going above or below from our angle here on Earth. Now, looking one at a time at a star to see if there's a transit, that's not a very effective way to do that. What you want to do is you want to monitor thousands or perhaps hundreds of thousands of stars all at the same time. And so you can't do that with a person looking at a star through a telescope. You need a dedicated robotic satellite. We have such a thing. It's called Kepler. The Kepler mission was a space telescope that stared at the same part of the sky for several years and monitored over 100,000 stars. And it actually discovered thousands and thousands of planets around other stars, thousands and thousands of exoplanets. Now, unfortunately, the part of the space telescope that allows it to stay pointed at that one direction in the sky has broken. So now Kepler is in a different part of its mission called the K2 mission, where it is still looking for exoplanets, but it's also looking for variable stars and other things in the sky. So while we can sort of mourn the loss of Kepler as being the most productive discoverer of exoplanets that humanity has ever invented up to this point, Kepler is still sending back important information.